Alright, what Theorem 18 tells us is that if we have some series that's some power series, the form a to the n x n, and we know that for x is equal to c that the series converges, then that tells us that we have absolute convergence for the absolute value of x is less than c. So if we look at a number line and we're centered at 0, and we know that we converge at c, we know that there is now a situation where we get convergence everywhere from minus c to plus c. We have absolute convergence. On the other hand, it also tells us that if x equals d, we get divergence. Then we know that here we're going to assume we're centered at 0 here. At d, we know that we get divergence anytime that the absolute value of x is greater than d. So that means over here, this is all divergence, and over here, minus d, we also get divergence over here as well. Okay, so that's basically Theorem 18, and it's going to work into the idea of a radius of convergence for a power series. We've talked about the convergence theorem now. As a practical matter for solving problems in 8.7, what does this suggest, and how do we go about doing it? I think that we know from Theorem 18 that if a power series converges for x is equal to c, then we know that it converges absolutely for x is less than c. Alright, but this suggests a test. This suggests a way of finding where a series converges. Instead of doing it this way, why don't we just ask the question, what is the range of absolute convergence of a function, of a series rather, and then so we would find this. Let's say we do a test like the ratio test. We find the absolute convergence of a function. Let's say it's centered at 0, and we find out that this c value is right here, c, and then we know for all this inner area we get convergence. The one thing we don't know, because this is a less than sign, we don't know what's happening at these 2 points, and we have to go back and individually test the endpoints. But because we know that if this is true, everything in between here converges, the only thing we're left to do is test this. Several of the homework problems are based on this principle. What you do first thing is, we're given a problem like in example 3, and you go through and you have a series, and you say, okay, you apply the ratio test to look for absolute convergence, and then you test the endpoints.